Hey there, fellow knowledge explorers. In the vast world of computer science, sorting algorithms are the unsung heroes that bring order to chaos. Just like arranging your books alphabetically or your toys by size, sorting algorithms help us organize data efficiently. Today, we're diving deep into the fascinating realm of merge sort, a powerful tool that simplifies sorting and fuels countless applications we use every day. Get ready to unravel the secrets of this ingenious algorithm. We'll explore what it is, why it's important, and how it works its magic. So buckle up and join me on this exciting adventure as we demystify the world of merge sort together. Imagine you have a deck of cards all shuffled up. How would you sort them? You might try arranging them one by one, but what if you had hundreds or even thousands of cards? That's where merge sort comes in handy. Merge sort is like a master organizer for your data. It's an algorithm that sorts a list of items by breaking it down into smaller, more manageable chunks, sorting those chunks, and then merging them back together in the correct order. This elegant divide-and-conquer strategy is what makes merge sort so efficient and powerful. Now, you might be wondering, why should we care about merge sort? Well, my friends, merge sort is like that reliable friend who always shows up on time and gets the job done right. It offers several advantages that make it a favorite among programmers and computer scientists alike. Firstly, merge sort is known for its consistent performance. No matter the initial order of the data, it always takes a predictable amount of time to sort it. This predictability is crucial in many applications where time is of the essence. Secondly, merge sort is what we call a stable sorting algorithm. This means that if you have two items with the same value, they'll stay in the same order they were in the original list. Think of sorting a class roster by grades. Students with the same grade will remain in alphabetical order. Finally, merge sort is well suited for handling large data sets that don't fit entirely in memory. It can efficiently sort data stored on disk or across multiple machines, making it a go-to choice for big data applications. Section 4. Unveiling the magic how merge sort operates. Alright, let's roll up our sleeves and see merge sort in action. Imagine we have a list of numbers, 8, 3, 1, 7, 0, 10, 2. Here's how merge sort would tackle this unsorted bunch. First, we divide the list into halves until we have individual elements. So, our list becomes 8, 3, 1, 7, 0, 10, 2. Now we compare and merge adjacent pairs of elements, creating sorted sub-lists. 3 and 8, 1 and 7, 0 and 10, 2. We continue merging the sorted sublists, creating larger sorted lists, 1, 3, 7, 8, 0, 2, 10. Finally, we merge the two remaining lists into our fully sorted list, 0, 1, 2, 3, 7, 8, 10, and voila, our list is sorted like a charm. The beauty of merge sort lies in its recursive nature, gracefully breaking down a complex problem into smaller, solvable steps. Section 5. Merge sort in action real-world applications. Merge sort's efficiency and versatility make it a star player in various real-world scenarios. Let's explore some of its shining moments. Databases rely heavily on sorting to retrieve and present data efficiently. Merge sort helps them handle large volumes of information with speed and accuracy. Ever wondered how online stores sort products by price, popularity, or rating? Merge sort plays a crucial role in delivering seamless shopping experiences. Social media platforms use merge sort to present posts in chronological order or based on relevance, ensuring users see the most engaging content first. From movie suggestions on Netflix to personalized product recommendations on Amazon, merge sort helps these systems analyze user preferences and deliver tailored experiences. These are just a few examples of how merge sort quietly powers the applications we use daily. Its impact is vast and far-reaching, touching various aspects of our digital lives. Section 6. Advantages and disadvantages of merge sort. Like any good tool, merge sort comes with its own set of strengths and weaknesses. Let's break them down. Advantages. Merge sort consistently delivers predictable performance regardless of the initial data order, making it reliable for time-sensitive applications. It maintains the relative order of elements with equal values, crucial for preserving order in specific scenarios. Its ability to handle data larger than memory capacity makes it ideal for sorting massive datasets. Disadvantages: merge sort requires additional memory to store temporary data during the merging process, which can be a limitation for memory-constrained environments. Implementing merge sort can be a tad more involved compared to some simpler sorting algorithms. Despite its minor drawbacks, merge sort's strengths make it a go-to choice for various applications where efficiency and reliability are paramount. Section 7. Conclusion. Embracing the power of merge sort. As we conclude our exploration of merge sort, I hope you've gained a newfound appreciation for this elegant and powerful algorithm. From sorting your favorite playlist to powering complex data-driven applications, merge sort's impact is undeniable. Its ability to efficiently organize vast amounts of data forms the backbone of countless technologies we rely on every day. Remember the key takeaways: its divide-and-conquer strategy, its predictable performance, and its stability. So the next time you encounter a sorting challenge, remember the magic of merge sort and its ability to bring order to chaos. Keep exploring, keep learning, and keep the spirit of curiosity alive.